because there's actually two angles here. No, that shouldn't make a difference. No, there are two angles. At this point, we eliminated the negative solution. That's the problem. All right. Questions before I erase most of this and not purge it from your memory, but at least perhaps replace it with something different. A couple years ago, I did one of those, like, asked students for a suggestion, and then I got to a certain point and I just begged the students never to make me do that again. So, yeah, I think next time I'm gonna nip that one in the bud. Let's solve for time. So time is 207 over 40 cosine theta. Plug that into here and here. So I get negative 50 is equal to, well, I have 40t here, I have 40 here and a 40 there, that's going to cancel out. So what I'm left with is t times 207 over cosine of theta, no, sorry, there's no t there, times sine of theta, because we're substituting in for t, minus 1.86, 207 over 40 cosine theta squared. So this, yeah, just for completeness, let me throw the 40 in there and then we're going to get rid of them. 40s cancel out. So negative 50 is equal to, well, I have 207, and then sine divided by cosine, which is tangent, minus, over here we have the 1.86 times 207 squared over 40 squared, and then we'll have 1 over cosine squared. So whatever that number is, times secant squared theta.
$49.8.
49.8. Is that, Mario, was that you?
Yeah.
Okay, 49.8. All right. So now I have an equation, a single equation in terms of a single unknown. Progress. How do we solve this? Is there perhaps a trig identity?
Yes.
What is the trig identity?
1 plus tangent squared theta is equivalent to secant squared theta.
And we plug that in for this. Because I don't feel like writing, I'm going to use a substitution here. I'm going to let, what letter do I not use much? I'm going to just let letter P equal tangent of theta. So I get negative 50 equals 207p minus 49.8 times 1 plus p squared. Distribute negative 50 equals 207p minus 49.8 minus 49.8p squared. Now we're left with a more obvious quadratic, or I guess officially a quadratic equation. Let's get it into the right form, use the formula. So 49.8p squared minus 207p plus, minus 0.2 equals 0. P equals 207 plus or minus the square root of 207 squared minus 4 times 49.8 times negative 0.2 divided by 2 times 49.8. We will get 2 answers. We cannot eliminate either of them. One's going to be slightly negative. And the other one's going to be about 4. What do you get? 4.15. Or
Negative 9.65. I did that right.
But that's 10 to the power of minus
Oh, yeah,
4.
yeah, I'm sorry, I didn't.
That was like negative 9.66 times 10 to the minus 4.
okay. Negative 0.00096.
Mhm.
6?
Mm-hmm.
Okay. All right, slightly negative and somewhere around 4. All right, those are not our final answers because that's the tangent of theta. Don't forget just the substitution over there. So theta is the arctan of 4.15. And my gut tells me it's somewhere around 76 degrees or so. I hope. Whatever we got last time.
76.5.
76.5.
Yeah.
And the arctan of this tiny little number right here, which is going to be somewhere around 0 degrees.
.055.
Wait, 0.055?
It was negative, does that matter?
Yes, it does.
Yeah.
Which means that when I'm throwing it off the cliff, let's see, 90 degrees is this way, so I'm throwing it at an angle like that, or I'm just below the horizontal and throwing it like that. So one of the solutions, it's going to be thrown just below the horizontal, and the other one is going to be thrown up, and they both land at the same spot. So anyway, a different way of solving the same thing. And I will assume all of you are just a little bit better human beings now for having gone through that. Character growth, if nothing else. Any questions? You can pretty much be guaranteed there's going to be a projectile motion problem of some sort on the test. Now let's change that. You are guaranteed, not pretty sure. You should know there will be a projectile motion problem on the test of some sort.
Is there an easy way to tell which variable you should solve for when you get into a situation of 2 equations? Or do you just have intuition?
I think it's primarily intuition. There's a problem that I've done before called I call it a projectile pendulum. I think it's called an interrupted pendulum is the official name for it, where I solved it this really long way. I came out with the right answer because I was able to eventually look at a solution. But I solved this really long way, and then I was doing this in class, and I opened it up to the students and say, hey, what do you want to solve for? And similar to what we did then. And they suggested solving it the other way, using the other equation. And it was done in about a fourth of the time. So the best way to do it is the way your mind is working at that moment. Now, something I do have to remind myself when I'm writing the test is that it's not a math test, it's a physics test. But sometimes you get carried away and go, wow, this will be really interesting. I wonder what the students are gonna do. And then I just throw it out there just as to see what students will do. All right, so now, why are there 360 degrees in a circle? Whom do we blame? Somewhere someone just came along and said, 360 sounds right, feels right. Pre-Aristotle, actually. But got my ancient history right.
Pythagoras?
Not Greek, was not the Greeks.
Not the Greeks?
Like going through your head about what civilizations were before the ancient Greeks.
Egyptians? Ancient Egyptians?
Not the Egyptians, I was trying to remember where these people came in line with the Egyptians.
Sumerians?
You're closer. Babylonians.
Babylonians.
Babylonians. Babylonians realized that the number 60 was very special. Now, today they had a base 60 system. Now, we can look at it now in our system and go, well, it actually is pretty remarkable because it's divisible by 1, 2, 3, 4, 5, 6, and then 10, and then you start whatever the counterpart to the numbers I just laid out. It's divisible by a bunch of numbers. Now, they associated it to religious significance, but they realized it was special. They also recognized that an equilateral triangle is special as well, and so why not combine the two? And this is 60, 60, and 60. To my knowledge, they didn't use degrees, but they assigned 60 to it. And then if you take 6 equilateral triangles, you can put them in a wedge, and it's 360 degrees all the way around. Obviously, man-made. So the question is there something natural to circles? Presumably you are all familiar with this. Something natural to circles. And they realize all circles have a circumference, they have a diameter, and so the ratio, as you've seen in a lab, potentially, that ratio seems to be the same for every circle. So they came up with this idea that if I wrap it around, and I know this is review for most of you, wrap it around, if that's the radius, and you wrap it around, that's a radius. So if my arc length is equal to the radius, this is equal to 1 radian. Or we generically, we have S is equal to R theta. Arc length is equal to the radius times the angle, assuming it's in radians. And so now let's take a derivative. The radius of the circle is a constant, so taking a derivative of a constant is going to get you nothing. So I take the derivative. So what's the derivative of distance with respect to time?
Velocity.
Scalar.
Scalar. Speed.
And then derivative of an angle with respect to time?
Angular velocity. Angular speed.
There we go. I got really clever with the names there. Angular speed, rotational speed would also work, but this is angular speed. In SI units, it have units of radians per second. So I want to sort of put that on the side burner for just a second. So we have S is equal to R theta, V is equal to R omega. About to do a derivation here. So the question is, do we want to do the calculus derivation or the non-calculus derivation? I think Marisol is speaking for all of you.
Dealer's choice.
All right. Let's go calculus. So I have an object here. I have my coordinate system here. I have an object itself radius r. And it is traveling at a constant speed, but obviously changing velocity, in a circle. So v dot is equal to 0 meters per second squared. V vector dot is not 0. So speed is constant, but velocity is not. So how can velocity be changing if my speed is constant?
The direction is
Okay. So my position at time t is equal to my radius times the cosine of theta, I hat, plus r sine theta, j hat, setting up our coordinate system, which I should have done to start with. And to find velocity, we just take the derivative. So if I'm taking a derivative with respect to time, I got three things here. What's constant?
R.
Okay, r is constant. Is that it? Oh, I guess I need to define theta here. There's theta. As this thing is traveling in a circle, or I guess going this way, is theta constant? There was a no, not a confident no there. Kyle, I think, was that Kyle or Lawson who said no? You want confidence in that, or you want to still leave it, walk the edge there?
I would like a confidence at the moment, so.
As this thing travels in a circle, is the angle with respect to the positive x-axis, to the positive horizontal axis, is that angle constant?
No.
There we go. All right, that was more confidence that time. And what about I hat? Is I hat constant? It is indeed. It's to the right. So r, I hat are constant, so I'm just taking derivative of cosine. So derivative of cosine is negative sine theta, and then by the chain rule, the derivative of theta. Plus, similar reasoning, r j hat times the cosine of theta times theta dot. Let's write this out to slightly more standard form. Negative r theta dot is just omega. Negative r omega sine theta I hat plus r omega cosine theta j hat. Let's see if this makes some sense at least. My velocity, let's assume theta is a first quadrant angle. The sine is a positive number, r is a positive number, omega is a positive number, it's a speed. So therefore, this, the part that I just boxed is a positive number, which means my velocity in a first quadrant angle is in the negative I hat direction. Well, check, because we're going to the left. And the j hat is, well, that's all positive also, so it's in the negative I hat positive j hat direction, that does match what we see. We got one other relationship we can exploit. What is the relationship between v, the velocity, and the radial vector? For something traveling in a circle.
Can you repeat the question, please? Always vertical.
The relationship between the velocity vector and the radial vector here.
Always vertical. Perpendicular?
That's the word.
Oh, sorry, perpendicular. yeah.
Yes, they're perpendicular. Well, how can you tell if two vectors are perpendicular?
The dot product is 0.
Absolutely. Let's see if it's true. Is r hat dot v, sorry, not r hat, but r vector dot v vector, is it equal to 0? Well, when you're doing dot products, you multiply like components here. So I have I hat and I hat, so I multiply those. So I get negative r cosine theta times r omega sine theta. Plus, that's from multiplying the I hat. Multiply the j hats, I get r sine theta times r omega cosine theta. They are in fact the same. So we've done something right, the fact that our velocity points in the right direction and it is perpendicular to my radial vector. And then quick side note, Babylonians, before or after the Egyptians, ancient Egyptians? Were they simultaneous? Before, okay. All right, so we have velocity there, except I actually want to find the acceleration, which is just the time derivative of velocity, or for those who prefer the more traditional. So I got my equation right here. What's constant? Or what isn't constant?
It's sine theta.
Say it again, Enrique.
Sine theta, so wouldn't be constant, right?
Okay, true. Or generically theta, just the theta piece. All right, so the rest of it is constant because omega is constant because it's traveling around at a constant speed. Therefore, by this equation, if speed is constant and r is a constant, omega better be constant. So our derivative, we got negative r omega, the derivative of I hat, times the derivative of sine, which is cosine theta, times theta dot, plus, then we got r omega j hat, times the derivative of cosine, which is negative sine theta, times theta dot, again, chain rule. There's my acceleration. Ugly looking, but we're gonna make that nicer. Theta dot is just omega. So I have negative r omega squared I hat cosine theta minus r omega squared j hat sine theta. Let's do a little factoring. We'll take out the parts that we can. We got this, which we can take out. So I got negative r omega squared, then cosine theta I hat plus sine theta j hat. Well, what is cosine theta I hat plus sine theta j hat?
Shouldn't it be 0? Or no?
No.
One. Yeah.
No, not one. It's not, I'm not looking for a number here.
Component.
Of, Well, if they're components, then let's take a look at just this piece right here. So it's going cosine theta I hat plus sine theta j hat. So the resultant is right there. What's the magnitude of the resultant?
Pythagoras.
Okay, what's the magnitude of the hypotenuse?
The Pythagoras theorem,
That's the one probably you should use.
sine squared theta plus cosine squared theta. And then you take the square root.
Okay, so this is the square root of cosine squared theta, you said it the other way, so we'll stick with that. Sine squared theta plus cosine squared theta. Okay. We can simplify that.
Square root of 1.
I heard two people speaking softly,
Square root of 1.
which is,
One.
okay. So this cosine theta I hat plus sine theta j hat has a magnitude of 1, which makes it what kind of vector?
A unit vector?
Yes, it's a unit vector. Pointing in what direction? In other words, what angle is that?
45.
Only because I drew it that way, but not generically. We're looking for something generic.
Theta?
Yes. It's theta. So this cosine theta I hat plus sine theta j hat is a unit vector pointing in the direction of theta. Huh. What else is pointing in the same direction as theta?
Right.
I'll go with the spirit of it. Radial vector. So that this right here is just a radial unit vector. It's pointing in the same direction as the radial vector. It's a unit, so it's a radial unit vector, otherwise known as r hat. It's a specialized unit vector which always points away from the center. So we have this acceleration is equal to negative r omega squared r hat. We can mess with this a little bit for more than just the fun of doing the math. So my acceleration is negative r omega squared r hat. I know that v is equal to r omega, or omega is equal to v over r. So let's make that substitution over here. So negative r v over r squared r hat, which is negative r v squared over r squared r hat, which is negative v squared over r. And if you've had physics before, this definitely should seem familiar to you. Up to this point, we have dealt with acceleration, been more explicit with it, the acceleration because of a change in speed. We're now dealing with acceleration because of change in direction. The direction of this acceleration is in the negative r hat direction. And what is the negative r hat direction?
Pointing towards the center.
Absolutely. With a magnitude of v squared over r. This is known as centripetal acceleration. those who have had physics, hopefully you did not, that you were able to code switch from everyday language into actual physics language, and for those who haven't had physics before, it is centripetal or centripetal, depending on how you want to pronounce it. I think one's more American, the other one's more British pronunciation, I'm not quite sure. But it's not the other one that people use too often. I'm gonna write the other one down, talk about it briefly. Might talk about it again briefly later on. But I just want to contrast that it is not the one that people use. Not centrifugal acceleration. Let's take a look at the words here. Center. Fugue, I think Latin. What word do we have that has a similar root, the F-U-G? Or the famous Latin expression, tempus fugit. Anyone know what tempus fugit means? What's a fugitive?
From the underway.
Center fleeing. Centrifugal is center fleeing. Tempus fugit means time flies. So if something's going away from the center, that's when this is appropriate. Centripetal, the PET, is a towards competition, as the same people come together for a competition. This is center seeking. There is rarely a case in this course when centrifugal is an appropriate thing to be using. There is a way of using it correctly. Most people do not. When you're going in a car, going around a curve, there's no centrifugal force acting on you. What's happening is your body is trying to go in a straight line and the car is cutting